So, if you're building anything with large language models, you have definitely noticed that the number of tools and frameworks is just exploding, right? It feels like trying to build a house when you've been dropped in a massive hardware store you've never even seen before. Well, in this explainer, we're going to hand you the blueprint. We are going to break down the entire LLM stack, from the absolute foundation all the way to the roof, so you know exactly which tool to grab and when. Okay, let's just dive right in. This is the big picture. And I know it looks a little intimidating at first glance, right? But here's the thing. Every single successful LLM application out there, from ChatGPT down to a custom chatbot you build yourself, is built on a stack just like this. And each layer, it just solves one specific problem. So today, we're going to demystify this map piece by piece. Here's our game plan for today. We're going to start with how an AI is born, creating its core intelligence. Then we'll talk about making that brain actually useful in the real world. And finally, we'll cover how to turn it all into a real product that people can actually use. By the end, you're going to see how all these different pieces click together. Let's start at the very beginning. Phase 1 is all about creating the AI's brain, its core intelligence. You can think of this as the forge. This is where we take the raw potential of a model and hammer it out, shaping it into something really powerful and capable. And at the heart of it all, the absolute bedrock is layer 1, training. Honestly, you can think of it like a kid learning a language for the first time. The model gets exposed to this massive library of text from all over the internet, and it just starts to pick up on the patterns, the grammar, the knowledge. This is where it learns to set its internal neural weights, which are basically the building blocks of its understanding. Now, this is where it gets really interesting, because training isn't just a one-and-done kind of deal. It happens in 3 key stages. First, there's pre-training, where the model just gobbles up a huge chunk of the internet to learn, well, everything. Then we fine-tune it with really specific examples, kind of like a teacher giving a student a worksheet. And finally, we align it with human feedback, which basically teaches it how to be helpful and to follow our instructions. So how do developers actually do all this? Well, they've got an incredible toolbox. The Transformers library is the foundation, kind of like the engine of a car. But the real magic these days comes from tools like PEFT, which stands for Parameter Efficient Fine-Tuning. This lets you customize these huge models without needing a supercomputer. It's like adding a turbocharger to your engine, instead of having to build a whole new one from scratch. Okay, so we've built this incredibly powerful but absolutely massive digital brain. It's like having a supercomputer sitting in your garage. But now you have a new problem, a really big one. How do you get it to run on something like your phone? How do we make it fast enough and cheap enough to be actually useful in the real world? Well, the answer is layer 2 optimization. This whole step is about making the model smaller and faster without losing all its smarts. The best analogy is a zip file, but for an AI. We're compressing it down so it's way easier to handle, which makes inference, getting predictions from the model, much, much quicker and cheaper. And there are 2 main ways this happens. The most popular one is called quantization. Imagine you have a super high-resolution photo. Quantization is kind of like reducing the number of colors in that photo. It's still a great picture, you can tell what it is, but the file size is way smaller. The other technique is pruning, which is like a gardener carefully trimming a bonsai tree. We're just snipping away the least important connections in that neural network to make it leaner and more efficient. All right, so our AI has gone to school and it's hit the gym. It's smart and it's efficient. Now it's time for it to get a job. In phase 2, we're going to connect our model to the real world so it can actually answer our questions using up-to-date information. And this brings us to layer 3, serving. The serving layer is basically the engine that makes the model run. It takes our newly optimized model, puts it on a server, and creates a really simple way for other applications to ask it questions and get answers back. We do this through something called an API, which is like a universal translator between different pieces of software. And of course, you've got options here, and it really depends on what you're trying to do. This table breaks it down nicely. If you're building a real production app and you just need something easy and fast, LitServe is a fantastic choice. If you think you're building the next big thing and you need to handle tons of traffic, LLM is probably your go-to. And hey, if you just want to play around with a model on your own laptop, tools like Ollama make that incredibly simple. Okay, so our model is up and running, but there's still a huge problem. Its knowledge is basically frozen in time, like a history book that was printed back in 2021. If you ask it about something that happened yesterday, it's going to have no clue. So how do we give it access to new or even private real-time information? Well, the solution is this incredibly powerful technique that is completely changing the game for LLMs. It's called RAG.
RAG stands for Retrieval Augmented Generation, and the best way to think about it is like giving the AI an open book test. Instead of forcing it to rely only on what it's memorized, it gets to first look up the answer in a textbook, or search a private database, or even look on the internet. This lets it generate a way more accurate and up-to-date answer. It's a game changer.
Now, RAG is a team effort, and it's powered by two more key layers. You have layer 4, orchestration, which is like the conductor of an orchestra. It uses tools like LangChain to build the whole pipeline that goes and fetches the right data. And where does that data live? Well, that's layer 5, and it's often in these special vector databases, which are like super fast, super smart libraries optimized for finding the most relevant piece of information in a split second.
We are on the home stretch now. We've built the AI's brain, we've connected it to the world. Now for the final boss, turning it into an actual product that people can rely on. This is the final mile, where we make sure our application is reliable, scalable, and actually user-friendly.
And this involves a few absolutely crucial final steps. Layer 6 is evaluation. We gotta test the model to make sure it's accurate and not making things up. Layer 7 is deployment. That's where we package it all up so it can be used by thousands or even millions of people at once. Layer 8 is monitoring, where we keep a close eye on it to make sure it's behaving itself. And finally, layer 9 is the application itself, the shiny front end that our users will actually click on and interact with. So, we've covered all 9 layers of the stack. It's a lot, I know, but now let's put it all together. Let's look at a quick case study to see how all these pieces really connect in a real-world project. Okay, imagine you're building a custom chatbot for your company. First, you'd use transformers and PFT to fine-tune a model on your specific company data. Next, you'd use something like Litserv to deploy it as a super fast API. Then, you'd bring in LangChain and a Chroma vector database to give it access to all your internal documents using RAG. And finally, you'd build a simple chat window with a tool like Streamlit. See how each layer has its own specific job? It really is like an assembly line for AI. And that, right there, is the key takeaway. The beauty of the modern LLM stack is that it's like a set of Legos. It's modular, it's composable. You are not stuck with some one-size-fits-all solution. You can literally pick and choose the best tool for each job and build a custom stack that is perfectly suited to whatever you're trying to build. And that really brings us to our final and maybe most important point. This entire ecosystem of tools proves that LLMs have evolved. They aren't just models anymore. They are true platforms for building a whole new generation of intelligent applications. So the question is no longer, what can AI do? The real question is, what are we going to build with it?